Assalamu alaikum banat. We are back again with a video for lesson 1.1 key features of functions. This lesson we have like multiple ideas. First idea, we have 5 key features to find. Second idea, we have the same key features but with a graph, so one of them with an equation, then with a graph. And then third idea, when we have a graph but we want to find 4 key features, they are only we can only find them within a graph. We can find them with an equation, but this is not part of the lesson. And last one is average rate of change. Okay, so you can skip through the video if you are if you want to just go directly to one of the ideas. Okay, so let's start with the first one. Finding key features given an equation. We have 2 types of equations, quadratic and absolute value. And the 5 key features we want to find at the beginning are vertex, domain, range, x and y intercepts. So let's see. I wrote here some notes that can help you. You already guys have them, and you can refer back to these notes whenever you want to have a clear idea. So when you have a quadratic function, to find the vertex, you have to use a specific formula. Remember the vertex, when I ask you about the vertex, I want you to give me the x and y values. So the x of the vertex, to find it, you can use this formula. The y of the vertex, you just find the x, substitute it back in the equation, and then evaluate to get the answer, which is going to represent the y of the vertex. And this whole thing, we're still talking about this vertex, the minimum or the maximum. Okay, one more thing is, if your a was positive, then it's open upward, then we have the vertex as a minimum. If your a was negative, then your function is open downward, then you have it as a maximum. Okay, so if your a is positive, then it's a minimum. If your a is negative, then it's a maximum. And what's the a? It's the coefficient of x squared. Okay, we're done with the vertex. Now moving to the domain, it's always from negative infinity to infinity, or you can just simply say it's all real numbers. Both are correct. Okay, the range is 2 types. Even one of the like either for when it's open upward or downward. If it was open upward, means that my a is positive. The range will be, because the range represents y values, then it's gonna be from the y of the vertex to infinity. Okay, the y of the vertex is included, it's part of the function, and the infinity is always open. If it was open downward, so it's gonna be from negative infinity, from downward, to the y of the vertex. This is closed, this is open. From negative infinity to the y of the vertex. Open, then closed. Make sure it's from the less, which is the negative infinity, to more, okay? Don't write from y of the vertex to negative infinity, because negative infinity is less. We're done with quadratics. Now to the absolute value, same things, same rules works, but the vertex is different. Here, the vertex is direct. You can just see it clearly from the equation. It's basically h and k. The h we take opposite sign, the k we take same sign. I'm going to explain that in a minute. This is my x of the vertex. This is my y of the vertex. Domain is always all real numbers. Range, same thing works here. If your a, the sign before absolute value, if your a was positive, then it's open upward. So your range starts from the vertex, y of the vertex, which is the k. Remember, it's basically the k from the y of the vertex to infinity. Open, and always this is closed. If it was downward, so from the negative infinity to the y of the vertex, which is your k. Closed, open. Tamam. Last 2 key features, the x and y intercepts. If you want to find the x-intercept, substitute the y by 0, like set your function equal to 0 and use the calculator to find the x values. Set your function equals to 0 and then solve. I'm going to show you how to solve. If you want to find the y-intercept, just make the x 0. Just go and put the x as 0 and then solve. Put the x as 0 and then solve. I'm gonna show you how to solve. Okay, so here we have two examples. These two examples, of course, they are not enough to understand everything about the lesson, but make sure you practice more examples. Okay, so I'm gonna solve first this example on quadratic function, and then I'll do the absolute value. So we want to find 5 key features. Given an equation, you can only find 5 key features. First, the vertex. I might ask you about the vertex. How to find it? Remember the vertex of a quadratic function. To find the x of the vertex, you have to use this formula. To find the y of the vertex, you just substitute. Okay, let's start finding the x of the vertex. It's basically negative b over 2a. Remember, the b is the coefficient of x. That's the b. The c, I don't have it, it's 0. The a is the coefficient of x squared. I don't care about the c now, I just care about the b. Okay, so it's gonna be from negative b, it's gonna be negative b over 2a. So negative 8 over 2 times negative 4, which equals to 1. That's my x of the vertex. So far, the vertex, I have the x as 1. Now let's find the y. How do you find the y of the vertex? Just use your equation. Instead of x, substitute 1. So negative 4 times 1 squared plus 8 times 1, which equals to 4. That's the y of the vertex. This is the x of the vertex, this is the y of the vertex. We're done with the vertex. Now the domain is easy. It's directly all real numbers. All numbers from negative infinity to infinity. Everything is part of the function. By the way, domain represents x values, if you remember. Lastly is the range. Range represents y values. Now to decide which formula of the range to use, you have to check if my graph is upward or downward. Check the a, it's negative. Since the a is negative, then it's downward. So my range will be from negative infinity to the vertex. But which value of the vertex? To the y of the vertex. So it's from negative infinity to the y of the vertex, which is 4. So to 4. The infinities are always open. The 4 is part of the graph, so that's why it's closed. Okay, done. Now let's continue working in quadratic function. Let's find the 4th key feature, which is y-intercept. How to find the y-intercept? Just set the x as 0. Take your equation, instead of the x, substitute with 0. This is going to be 0, this is going to be 0, so the y-intercept is 0. So I have a y-intercept. When x is 0, the y-intercept is 0. This is how we write the point. That's it. Last idea is the x-intercept. Just go and substitute the y by 0. So how do we do that? Use the equation. Instead of y, substitute 0. Negative 4x squared plus 8x. What do I do here? I find the zeros. I use like my calculator. Mod 5. It's degree 2, so I use number 3. The a is negative 4. The b is 8. The c is not here. It's 0. So use your calculator to find the zeros. Find the solutions. So it's gonna be, and okay. So I have two solutions, two x-intercepts. When x equals 2, and when x equals, how did I know I have 2? Because I have power of 2. When x equals 0. So these are two x-intercepts. How do I write them as a point? So the x is 2 when the y is 0. The x is 0 when the y is 0. Why is the y 0? Because we said it already. It's intercepting the x-axis. At 0 and at 2. The graph is going like this. It's cutting through the x-axis at these two values. Anyways, we're done with the quadratic function. Let's solve example of absolute value, but same things. So first, let's find the vertex. Vertex is easy. Just, it's only hk. H we take opposite signs, k we take same sign. H is inside the absolute value, the number inside, and k is the number added outside. So the h is gonna be positive 5. The k is negative 3. That's the h, that's the k. Or this is the x of the vertex, this is the y of the vertex. Same concept. Now, domain is easy. It's basically all real numbers from negative infinity to infinity. Last thing is the range. The range is, you just have to again check whether it's open upward or downward. If it's open upward, it's a case, or downward. How do we do that? You have to see the number before the absolute value. Miss, we don't have a number here. It's a hidden one, and since it's positive, always. If it was positive, if it was negative, they're gonna write for you a negative. Since it's positive, then we're gonna have it as a V open upward, not a U. Absolute values are V. And the domain is, the range, which is Y values, is gonna be from the Y of the vertex to infinity. What is my Y of the vertex? It's the same as the K, which is negative 3. So it's from negative 3 to infinity. Infinities are always open, and this is part of the function, so it's closed. Done. Let's find x and y intercept. So I'm gonna start by finding the y-intercept. Again, to find the y-intercept, just set the x as 0 and solve. So instead of x, substitute with 0. 0 minus 5 minus 3. But how do we evaluate this one? You can just subtract first. 0 minus 5 is negative 5. Then absolute value of any number, just keep, don't remove the absolute. This is not a bracket. This is absolute value. Absolute value of any number will change it to positive number. Tamam? Take the negative 3 down here. So 5 minus 3, 3 is the y. 5 minus 3 is basically 2. So the y-intercept is at 2. So I have a point when x is 0, the y is 2. Always the y-intercept, the x is 0. The x-intercept, the y is always 0. Okay? So let's do the x-intercept now. X-intercept, set the y as 0. Absolute value of x minus 5 minus 3. So how do you solve this? Just solve the equation. Isolate the x. First of all, cancel the 3. Take it here. It's going to be positive 3. Now you have 3 equals absolute value of x minus 5. Now, to break the absolute value, you cannot just remove it easily. You will remove it, but one time say that x minus 5 equals to my answer as a positive answer. One time you will say that x minus 5, which was inside the bracket, equals to my answer, but when it's, if it was, let me write it here, negative answer, okay? And solve separately. So take the 5 there, it's gonna be positive 5. Take the 5 here, it's gonna be, sorry, why am I doing that? Let me focus on one equation. Anyways, take the 5 here, it's gonna be positive 5, and then solve. X equals 5 minus 3 is 2. So I have a point when x is 2, the y is 0. Done. Let's do the other equation. Take the 5 here, it's gonna be positive 5. Then x equals 5 plus 3, it's 8. So one time we're adding 3, one time we're subtracting 3. So I have a point when x is 8, the y is 0. So these are the 2 points. Done. I think it's easy. There are just small tips while dealing with absolute value functions. Otherwise, I believe it's very easy. Fine. Let's move to the second idea. Key features given a graph. These are very clear, very helpful rules that can really be guide you through when to use an open bracket, closed bracket, or whatsoever. By the way, this is an open bracket, this is a closed bracket. طيب, when do we use an open bracket? When do we use a closed bracket? So I wrote for you, you use an open bracket when you have an open circle in the graph. How does it look like? Like this. When you have an arrow, like an arrow goes to infinity, like this one, okay? And we have some cases. When you are talking about positive and negative intervals, which is going to be our next slide, I'm not going to mention it out now. So simply when you have open circle or an arrow. Later on, I'm going to show you have some special cases for positive and negative intervals, increasing and decreasing intervals. Okay? So let's see. Before we start, just keep in mind that when you want to study a graph, domain represents the x values. So you have to look at the graph from most left to most right and see what is my most left, write it down. What is my most right, write it down, and just use the correct brackets for them, okay? Whether it's open or closed whatsoever. Range is basically your y value, so you have to go from the lowest to the highest and see what is this value, what is this value, and put them in brackets. Positive and negative, I'll talk about them later, increasing and decreasing later, okay? So, by the way, you can just use either the interval notation that we've been using from the beginning or the set builder notation. If you want to use it, you can use it. I already discussed this in class. I don't want to make this video any longer, but I'm going to move forward directly. X and the y-intercepts are basically, you can find them easily from the graph. X-intercept is the value where your graph is crossing your x-axis. Y-intercept is the value when your graph is crossing the y-axis. So let's see, I'm gonna find the 5 key features again. First, the vertex. Like, you don't have to, but it's just nice to find it. Domain, range, x-intercept, and y-intercept. So let's start by the vertex. I don't have a formula here to use anything. Just look at the equation. Where is the minimum or the maximum point? I have a minimum point here, which is at -1, -9. So I have a vertex at -1, -9. That's it. But you don't really have to find the vertex in this when you have a graph. They're not gonna ask you. It's just optional. And you use just a point bracket, but I'm not gonna confuse you, so I'm not gonna find the vertex. Moving to the domain. Domain, as we said, we don't have already numbered or whatsoever. You have to study your graph. So you have to look at your most left and your most right of the graph. So what's my most left point? The point that is on the most left here. It's an arrow, and since it's an arrow, without looking at what number I have, because it's an arrow, it's basically a negative infinity in the x values. Okay, I know it's in the x values negative infinity, and in the y value it's going up to the infinity, but because I'm talking about the domain, I will only care about the x values. So it's negative infinity on the most left, because infinities are always arrows, they are always open. Then my most right, it's going to the right to x values of infinity, and it will go up to y values of infinity. But I care about the x values only, so it's gonna be infinity. Open always for infinities. Range, I will go from the lowest to the highest point in my graph. So look at your graph. What's the lowest point? The lowest point is here. And it's closed. It's a connected line. I don't have an open circle. I don't have an arrow. Tamam? So it's a closed at what number? You look at the y value. Don't look at the x. Look at the y, because the range are y values. The domain are x values. Okay? Y value, so read the y value that you have it here. It's -9. Again, we closed it because I don't have a circle, I don't have an arrow. طيب, what's the highest value? I have 2 highest values, and both of them are arrows going to infinity in the y. Miss, but this one is going to negative infinity of the x. I don't care about the x. I only care about the y because I'm talking about the range. Okay, so infinity, and infinities are always open. Okay, x-intercept. Look, when is my graph crossing the x-axis? It's crossing at -4, so when x is -4, and at 2, when x is 2. How do we write it as a point? You say when x is -4, the y is 0. When x is 2, the y is 0. What's the y-intercept here? At -8. So when y is -8. So you can say it as when x is 0, the y is -8. Done. This is how we do it. Let's take this graph. So I'll find the domain. Remember, domain are basically x values. So you take from the left to the right. From most left, I have this point. I read the x value of it, it's -4. And it's open circle, so I open it. 2. Most right is this point. It's basically at 4. I read the x value at 4. It's a closed circle, so I have to close it. تمام? Range, which basically y values from the lowest to the highest. See, domain and range here, you have to study the graph. You don't have to use any equation because you don't have أصلا any equation to like use. What's my lowest point here? It's this one. This is the lowest. What do we read, the x of it or the y? We read the y because we're talking about the range, the y values. The y is -1. Is it an open circle? لا. Is it an arrow? لا. So we close it. Easy. Now what's the highest point in the whole graph? This one. Do I read the x value or the y value? I read the y because I'm talking about the range, which is 3. Is it an open circle? No. Is it an arrow? No. So close it. Lastly, x-intercept. Only look for the values where it did intercept the x-axis and it's closed there, it's connected. Like it did actually intercept the x-axis. So what's the x-intercept? I have an x-intercept here at -3, here at -1, and here it did touch it, it's closed at 4. So 3 x-intercepts at -3, -1, and 4. Y-intercepts, I have only one y-intercept at 1. بس. طيب. Next idea. We're gonna talk about 4 key features. Increasing means going up. Decreasing means going down. Positive means when my graph is above the x-axis. Negative when my graph is below the x-axis. Okay? These key features, they are very sensitive. You only read x values of them. You never look at the y-axis, you only read the x values. And they have some special cases for their brackets. So along with these cases, like when do I use open bracket? I use it when I have an open circle, when I have an arrow, and also when you are talking about positive and negative intervals, but you are on the x-axis. So if your point is touching the x-axis, if your end point, if the number you want to like use a bracket at is on the x-axis, you directly use open circle, even if it was closed. I don't care. This is only when we are talking about positive and negative intervals. And the reason behind it, because when you are on the x-axis, it's not positive, it's not above the x-axis, it's not negative, it's not below the x-axis, it's on the x-axis, it's 0. So that's why we keep it as open, because it's not positive, it's not negative. Okay? We have another special case for increasing, decreasing intervals. So sometimes when you are describing your function, you will say that, okay, it's increasing from I don't know where to here. Once you reach this point, and it's a maximum point or maybe a minimum point, this point is not increasing, not decreasing, it's temporarily stable. So let's say that this is your graph. From -4 to -2, it's increasing. Okay? Now, from -4, from -4, I kept it open because I have an open circle. To -2, now the -2, you'll tell me, Miss, it's closed circle, I have to close it. No. This is a very special case, we call it case 4. We keep it open because at this point, it's temporarily for 1 second stable. It's constant, not increasing, not decreasing. So you keep it open only when you are talking about increasing, decreasing intervals. Okay, it's not open forever. It's only for this special case. So if you have a maximum or a minimum, same thing goes for the minimum, like this, then that's case number 4. And this only special case for increasing, decreasing intervals. Okay? Now, when do we close the brackets? If none of these cases is happening. Okay? Let's see. So let's start with this graph. Let's talk about first positive intervals. Increasing, decreasing. Time. For positive, I'm gonna use this color and just shade. When is it positive? Positive means above x-axis. So this is when it is positive. Let me zoom in. Okay, perfect. This is where exactly the graph is positive. So from where to where? I just read from the left to the right, okay? And we always read x values from left to right. X values, okay? So I have from here, which is negative, 2. This is -1, -3. So from -2, just put the numbers first, to 2. Then think about the brackets. طيب. Now remember, I keep it open if I have an open circle, if it was an arrow, for positive and negative intervals, if it was on the x-axis, okay? And for increasing, decreasing intervals, if it was a maximum or a minimum, okay? Type. Now, is it an open circle? No. Is it an arrow? No. Is it on the x-axis and we're talking about positive, negative intervals? Yes, we are talking about positive, negative intervals, and it is on the x-axis. So unfortunately, I have to open it, although it's closed, huh? But this is a special case, which is case 3, okay? Now, same thing you're gonna study for number 2. Because I'm talking about positive intervals, I'm gonna check only these. The increasing, decreasing, هذا ما خصني. تمام؟ Yeah. Is it open? لا. Is it arrow? لا. Is it on the x-axis? Yes. So unfortunately, I have to open it. تمام؟ Yeah. Negative intervals. I'm gonna use this color. عشان قاعدة بلون على كيفي. يلا. This is negative, means under the x-axis. This is negative, means under the x-axis. So let's see. Let's first write for this interval. Let's see the most left and most right. Most left of this interval is this one. And it's an arrow going to where? What x values? Negative infinity in the x values and negative infinity in the y values. I care about the x values. Which is what? Negative infinity. 2. What is the most right? Negative 2. Now infinity is directly open without thinking. Now negative 2. Is it open circle? لا. Is it arrow? لا. Is it on the x-axis? Yes. Are we talking about positive, negative intervals? Yeah, we are talking about negative interval. So unfortunately, I have to open it. And what else? Let's see the other interval. It's from 2 to what? From the 2 to this arrow. Now this arrow is going to the positive infinity in the x values and negative infinity in the y values. But I care about the x values, so it's going from 2 to positive infinity. Infinities are always open. The 2, it's not open circle, it's not arrow, but it's on the x-axis, so I have to open it because I'm talking about negative intervals. That's it. Increasing and decreasing, same thing. So I'm just gonna erase whatever I did here. Again, so for increasing, decreasing, you have to consider first, second, and last case. This case, the third case, you don't have to look at it, لأنه you're talking about only increasing, decreasing. This one is only for positive, negative intervals. ما خصنا فيها. طيب, yeah. For increasing, let's shade when is it increasing with the green color. So it's increasing, it's going up in this part. So let's see, what's the most left? It's what? Read the x value. At the x, it's negative infinity. In the y, it's negative infinity, but I care about the x. So from negative infinity to, what's this value? Read the x of it. Please make sure you are reading the x values. It's 0. Don't tell me, miss, it's 2. La, it's not 2. We don't take the y. We take the x. 0. تمام? Infinities are always open. Now this 0, is it open circle? لا. Is it an arrow? لا. Now do we check this case? لا, because we're talking about increasing, decreasing. So we only check this special case for increasing, decreasing. Is it a maximum or a minimum? It is a maximum, right? So keep it as open. Unfortunately, although it's closed, but it's a special case. This is the increasing. Now what about the decreasing? Decreasing means when is it going down? This is going down. So that's my decreasing part. So let's see, from left to right, okay? So it's decreasing from the 0 to the here again. It's going to positive infinity in the x values and negative infinity going down in the y values. So it's going to the right, positive infinity, down, negative infinity. But I care about the x values. So basically, it's going to be from where? From the 0 to positive infinity. Infinities are always open, and 0, because it's a maximum, it's open. Done. Let me do with you this function. Okay. So let's see. Okay, again, write down on the side. I keep my bracket open if I have an open circle, if I have an arrow. If I'm talking about positive, negative intervals and I am on the x-axis. If I'm talking about increasing, decreasing intervals and it's a maximum or a minimum. Okay? Yeah. So positive. Let's start by positive interval. This is positive, means above the line. This is positive, means above the line. Okay? So let's see. Let's read this first, this interval. From most left to most right. From the left, it's positive from negative 4. Make sure you always read x values. To negative 3. Again, negative 4. Is it open circle? Yes, directly open. طب negative 3. Is it open? لا. Is it arrow? لا. Is it? Check this case because we're talking about positive, negative cases. Is it on the x-axis? Yes. So keep it open because it's not positive, not negative. And what else? From this number, from negative 1 to 4. Again, you always read x values. طيب at -4 is it open circle؟ لا. is it arrow؟ لا. is it on the x-axis؟ yes, keep it open. طب 4 is it open circle؟ no. is it arrow؟ no. is it on the x-axis؟ yes. بس miss it's closed circle. I don't care. It's a special case that says if you are talking about positive negative intervals and your point is on the x-axis ان شاء الله مو بس تكون closed circle، ان شاء الله تكون عليها خرزة زرقاء. I don't care, make it open. This is a very special case for positive negative intervals. يلا negative intervals. مقروقني قاعدة بلون. Anyways, so I have a negative interval from -3 to -1. I can see it clearly طبعا. طيب this is on the x-axis, this is on the x-axis, so it's case 3. Open, open. خلاص. Increasing. Let me erase whatever I did here. For increasing, you're looking for when is it going up. So it's going up from, what do I read, the y values or x values? Of course the x values. From -2 to, read the x values always, to 2. So from -2 up to 2. Now let's see the cases. Is it open circle? لا. Is it arrow? لا. I'm talking about -2. Do we check if it's on the x-axis? No, we don't check this case, please. We check the fourth case, okay? Because we're talking about positive, increasing, decreasing. Is it a maximum or a minimum? Yes, it's a minimum. It's a stable point. It's not increasing, not decreasing, so I keep it open. Same thing here, it's a stable point, so I keep it open. Now decreasing. This is decreasing and this is decreasing. Yeah. So I'll start with this one. It's from -4 to -2. Hello. -4, it's open circle, directly open it because it's one of the cases. -2, it's a stable point, it's a minimum, so I keep it open. Also, from the 2 to the 4. Yalla. From the 2 to 4. The 2 is also a stable point. It's case 4. We're talking about decreasing, so I have to open it. It's stable. It's a maximum. So open it. طب the 4, is it open circle? لا. Is it arrow? لا. Do we check this case? Nope, because we're talking about increasing, decreasing. I don't look at this case أصلا. طيب, is it a maximum or a minimum? لا. It's not a corner. Like it's just a line that stopped here. So I keep it as it is, closed. It's none of the cases. Got it? It's none of the cases, so that's why I closed it. Fine. This one is the same concept. I'm not gonna do it. I'll just do this question. So he said that the function in this graph is positive in this interval. So he said it's positive from -1 to 5, 4, 5. So from here to here he said it's positive. No, it's not. That's increasing. وأصلا interval غلط, not to 5, to infinity. And it's negative from -5 to -1, had decreasing. And it's not from -5, from -infinity. So he is incorrect because blah blah blah. He's talking about increasing, decreasing, not positive, negative. And you can simply correct his mistake by actually writing when is it increasing, when is it decreasing. When is it positive, when is it negative. So just write down it's positive when here from the 2 to infinity. Infinities are open and 2 is open because it's on x-axis. And also from here, from -infinity to the 4, -4. Yes, this is going up, but it's on the x-axis, it's going to -infinity. Okay, on the y is going to infinity, but I care about the x value. From -infinity to -4, both are open. This is an arrow, and this is on x-axis. طيب, and it's negative, just correct him. When? From -4 to 2. And both are on x-axis. Okay. Last idea. Average rate of change. The equation for average rate of change f of b minus f of a over b minus a. That's it. طيب, how do we do that? We have two possible ways of asking a question about rate of change. We either give you a graph or a function. If I gave you a graph, that's easy. You just have the f of a, f of b, you have everything. Use the function. Before you use it, just identify your a, your b, your f of a, and your f of b. How do we know? We would give you an interval, obviously. The first number will be your a, the second number will be the b. So that's the a, which is -2, and that's the b. So I want the change from -2 to 0. Find the f of a from your graph. So go to -2 and x values. Okay, check what's the y of it. It's 4. So when it's -2, the y is 4. That's it. Type. Go to 0 and x values, find the f of b of it, find the y of it. Okay, so when the x is 0, the y is 0. And then plug in, use your function, f of b minus f of a over b minus a. So 0 minus 4 over 0 minus -2, which is gonna be -2. If you put this in the calculator, this is the average rate of change. And it's negative because it's decreasing. It means that the graph is actually decreasing, it's going down. طيب, what if I have an equation? How do I find average rate of change? Same concept, but you have to calculate your f of a and f of b. So first, find your a. They gave me an interval. This is a, this is b. A is -2, b is 0. Okay? طيب, how do you find f of a? Use your function. Instead of x, put your a, which is in this case -2. So it's going to be 1 over 2 times -2 minus 1, which is -2. Okay? That's my f of a. Find your f of b. 1 over 2 times your b minus 1, which is going to be -1. And use the function f of b minus f of a over b minus a, which is f of b is -1 minus f of a is -2 over b minus a. And the answer would be, here it's 1 and here it's 2, يعني 1 over 2. That's your rate of change. It shows that it's positive. This means that from -2 to 0, the graph is increasing. We're done. Alhamdulillah. I'm done with this lesson. All details are given. You can use the notes and pack. I have a lot of resources for this lesson I shared with you earlier. They are very, very super helpful. Use them for reference, and good luck.